Okay, so in this video, we're going to deal with page 63, solving second-degree trig equations. So page 63, solving second-degree trig equations. All right, here's what your notebook page should look like. Page 63, I can solve second-degree trig equations. So second-degree trig equations are when you have your variables squared. That's what second-degree trig equations would mean. Now, in this case, we're not going to see x squared. We're going to see sine squared, cosine squared, tangent squared, or any of the reciprocals. All right, so if you're ready to go, take a look at our first example. So our first example is going to have us take a look at 9 tangent squared theta plus 5 equals 8. Now, you'll notice, guys, that up above each one of these examples, I gave you like some key words to think about or some strategies that you're going to use in each one. So we're going to talk about 3 different strategies today. We're going to talk about the square root method, trinomial method, and the greatest common factor, or GCF method. So when you look at this first example, we've got 9 tangent squared theta plus 5 equals 8. So if you think about what we did last class, we talked about getting our variable alone. So our variable here is tangent squared theta. So we can get this alone. We would subtract 5 from both sides. Okay, and over here we're going to get 9 tangent squared theta equals 3. And then you would divide by 9, so you'll get tangent squared theta equals, and then 3 over 9, you can leave it like that, or you can write it as 1/3. Now, when you have something squared equals theta, to solve that, you would take a square root. So we're going to take the square root of both sides. So tangent squared theta, the square root and the squared cancel, so you get tangent of theta equals, and now here we have the square root of 1/3. Now you could take the square root of those, or you can just leave it as the big square root. But what you have to remember is when you take the square root of something, you need to be thinking about positive and negative. All right? And that's what's really the big difference here, is that I now will need to think about where this fraction is positive and where it's negative. So the way we did this before, again, we're going to be solving for theta. We need to find the angle. So to find the angle, you're going to do inverse. So we're going to start by finding our reference angle. And when we find our reference angle, I'm going to do tan inverse of the square root of 1/3. Now, I have to be really careful when I type this into my calculator. So when I go to type this in my calculator, I have to do second tangent. And now I need to do the square root. And I want to take the square root of 1/3. And the parenthesis for the square root and the parenthesis for tangent. Right? And you get a reference angle equal to 30 degrees. So that's your reference angle is equal to 30. Now I actually need to find all the angles that make this true. So we need to be thinking about ASTC. Now, we actually need to be thinking about where this fraction was positive. So tangent is positive in the first and the third. But we also need to be thinking about where it's negative. Oh, it's negative in the second and the fourth. So I actually need 4 answers for this problem. So what are my answers going to be? Well, let's go through and think about that. So your first answer for theta is going to be your answer in the first quadrant. Your first quadrant answer is always equal to your reference angle. Your second quadrant answer, when you think about your second quadrant answer, you want to go all the way around, but you're 30 degrees short, so it's 180 minus 30, or 150 degrees. Your third quadrant angle, you want to go past 180. So 30 past 180 is 180 plus 30, or 210. And then your fourth quadrant angle, you want to be thinking about being short from 360. So 360 minus 30 is 330 degrees. So in this case, you actually have 4 answers: 30, 150, 210, and 330 degrees. All right, so when you're doing the square root method, you're basically going to solve for the variable. So I'm going to come over here and give you some steps. So when you're doing square root, right, you want to solve, get your variable alone, get your trig function alone, and then you want to take the square root of both sides, and then you want to make sure you consider positive and negative cases. Right? So that's what's important when you're going through and you're looking at this. You're going to get that trig function alone, take the square root of both sides, consider the positive and negative cases, and don't forget to find all angles. Now, I didn't go through and go back over the fact that you need to find a reference angle and all of that, but that's what you need to do when you're doing it. Okay, so think about that. Find your reference angle and then find all the angles in each of the cases. Okay, let's take a look at this trinomial example. So this one's going to be different than the square root method. It's going to be different than any of the methods we dealt with last class, because hopefully you'll notice in both of these two problems is that we have a squared term, but we also have a not squared term. And when you have a squared term and a not squared term, you can't put those together, which means you can't take square roots. You have to use your quadratic strategies, which is getting things equal to 0 and factoring. So when you see a trinomial, you're going to be thinking about factoring. You're also going to be thinking about like AM factoring. So whenever you're going to factor, you need your equation to be equal to 0. So in order to do that, I'm going to subtract 5 from both sides. So this becomes cosecant squared x minus cosecant x minus 2 equals 0. Now, keep in mind, guys, that this is a trinomial. All right? It's got 3 pieces. And when you have a trinomial, the way we factor a trinomial is we think about AM factoring. I need to think about numbers that are going to multiply to negative 2 and add to negative 1. So when you think about this, you're thinking about, oh, what multiplies to negative 2 and adds to negative 1? That's going to be negative 2 and positive 1. Now, traditionally, when you factor, you write 2 parentheses, set them equal to 0. Normally, in the first position goes an x and an x. But I don't want x squared, I want cosecant squared. So we write cosecant x, cosecant x. And then you're thinking, like we said, about what multiplies to negative 2 and adds to negative 1. That's going to be negative 2 and positive 1. Those multiply to give me negative 2 and they add to give me 1. Now, once you've done that part and factored it, now you can solve each one of these parentheses. So remember, when we solve each one of these parentheses, we draw our line and we set each case equal to 0. And then you solve each case. So in this case, I would add 2 to both sides. So I'll get cosecant of x equals 2. Here I would subtract 1. I'll get cosecant of x equals negative 1. Now, we actually have to find the angles for each one of these, and this x works just like a theta. So when you're working through this problem here, you want to first be thinking about cosecant of x being equal to 1, and the fact that you really don't have a cosecant button on your calculator, so I would change this to sine of x equals, and then flip that 1/2. So your sine of x is equal to 1/2. So we need to find our reference angle. So you have to do inverse sine of 1/2, and you can type that into your calculator, or you might recognize a triangle. It's up to you. So I'm going to do inverse sine of 1/2. Okay, I get an angle of 30 for my reference angle. And now I want to think about where sine is, in this case, positive, because it's a positive fraction. So sine is positive here and here. So that's giving me angles in my first quadrant of 30. And in the second quadrant, you're going to do, remember, this is 180, minus your 30 is 150 degrees. All right, now let's take a look at this next one. This next one is cosecant is equal to negative 1. So when you're thinking about this one, again, if you want to turn it into sine, your sine of x, if you do the reciprocal, is going to be 1 over negative 1. All right, so sine is going to be equal to basically negative 1 as well. And remember, when you get 1s and 0s, you should be thinking about your unit circle. So you have the point here of 1, 0, 0, 1, negative 1, 0, 0, negative 1. Now, when you're thinking about this, remember, you're thinking about your unit circle. Your unit circle is those points, x, y. Remember, this is cosine of your angle, sine of your angle. So sine is your y coordinate. You want to know where the y coordinate is negative 1. So if you go around, you're looking for the y coordinate to be negative 1, which is here. So that value, your angle x, is going to be 270 degrees. So in this case, you have 3 answers: 30 degrees, 150 degrees, and 270 degrees. Okay, look at our last example. So same kind of idea. You have a squared term and a not squared term. When you have that, you need to get your equation equal to 0. So to get this equation equal to 0, I'm going to add 2 cos x to both sides. And when I do that, I want to recognize that this is squared and this is not, so I cannot put those together. So this is 3 cosine x plus 2 cosine x equals 0. Now, this is not a trinomial. There are only 2 pieces. So if there are only 2 pieces, it's not a trinomial, but you still want to factor it. You got to be thinking about your GCF. What do they have in common? Well, in common with both of these pieces is cosine. So I'm going to divide a cosine of x out of each piece. Now, when I divide by cosine here, I get 3 cosine x still. But over here, when I divide by cosine, I just get plus 2, and that equals 0. Now, just like when we factored over in the other problem, we draw our line and we set each piece equal to 0. So this is telling me I want cosine of x to equal 0, and this is saying 3 cosine of x plus 2 equals 0. So I got to solve again each one of these cases. So when cosine is equal to 0, again, is that unit circle problem. So I'm going to draw out my points. 1, 0, 0, 1, negative 1, 0, 0, negative 1. And I'm looking for where cosine is equal to 0. So if you remember, based on this problem over here, cosine is your x-coordinate. So I want the x-coordinate to be 0. So my x-coordinate is 0 here in this part and in this part. That's where my x-coordinate is 0. So my answers for my angles are 90 degrees and 270 degrees for that part. Over here, I need to get cosine of x alone. So to get cosine of x alone, I would move the 2 over, subtract 2, and I would divide by 3. So I'm going to get cosine of x equals negative 2/3. So the first thing I need to do is find my reference angle. So I'm going to do inverse cosine of 2/3. Remember, I don't put the negative in because I want to figure out where it's the quadrants where it's negative after. I just need my reference angle. So I grab my calculator. I'm doing inverse cosine of 2/3, and I get a reference angle of about 48 degrees. So my reference angle is 48 degrees. I want to think about what quadrants I'm in. So remember, cosine is negative here. So cosine is negative in the second and in the third. Cosine is negative in the second and the third. And now I'm just going to find those angles. So again, x is my answer for the angles. In the second quadrant, I do 180 minus 48. So 180 minus 48 is 132. And in the third quadrant, it's 180 plus 48. And then again, 180 plus 48 gives me 228. And those are your 2 answers for that part. Your other 2 answers are 90 and 270. So when you're solving a second degree trig equation, you a lot of times end up with more than 2 answers. Sometimes maybe you only end up with 2, but a lot of times you could end up with 2 answers, 3 answers, 4 answers. You just got to be thinking about each of the quadrants. When you're factoring, you need to separate it into 2 cases and solve each case for the angles that it yields. All right, so if you want to go back here to this paper here, if you want to think about factoring methods, when you're factoring, which can be trinomial, which is where you use AM, or it can be GCF, right? When you're thinking about each of those, you want to get your equation equal to 0. So get equation equal to 0. And then you want to factor. And then you want to solve the 2 cases, right? You want to solve each of those 2 cases. And remember, you want to find all your angles. And you're finding all of those angles either by using reference angles, using the calculator, or you could be using your unit circle as well. Okay, so at this point, you should be ready to complete your classwork.